Okay, with kinematics questions, I like to start with my givens. So we'll start with part one of this question. How high does the cannonball go? So my givens in this case, we start with an initial velocity, which I'll call v1, of 20 meters per second up. And the other known that we have is the acceleration is 9.8 meters per second squared down. So that's the acceleration due to gravity. Now, because when we add or do anything with vectors, we want to make sure that the directions are all the same. So I'm going to make this the up direction the positive direction. And so that means I'm going to convert the acceleration to be negative 9.8 meters per second squared up. So that's the acceleration I'm going to work with. We also know that the change in displacement, because we're launching something off a cliff, it goes up a certain amount of distance, which we're trying to find, and then it eventually lands on the ground. Its vertical displacement is negative 1,000, and that's because the cliff itself is 1,000 meters high. And the difference in displacement, so delta D, the definition of that is dF minus di. Well, my dF, my final displacement with respect to the ground, is 0, and then my initial displacement with respect to the ground is 1,000 meters. So this ends up being negative 1,000 meters up. Another way of thinking about it is if you start the object here, it ends up down here. Well, it's below where it initially started by 1,000 meters. So that means my delta D is negative 1,000 meters up. Now the initial question said the delta D in kilometers. So because all of our units in all of these other variables are in meters, we have to make sure that the displacement also is in meters. So I've done that conversion. And then finally, we know that at the top of its journey, the projectile stops momentarily. So therefore, the final velocity at that particular point, so at this point, is 0. Now, there is another velocity at the second part of the question. It asks, how long does it take to hit the ground? The final velocity in that case would be some non-zero value. And that's because just before it hits the ground, the final velocity is a big number. Okay, so we have enough information now to solve part one. So we're going to look for this answer right there. How high is that? So that's my h value. So we're going to find h, and we're going to look for a kinematic equation that involves this, because we know that the final velocity at that position is 0. We're not going to include this notation, or sorry, this value here, because that doesn't involve this journey right now. We know that this is applicable, and we also know that that is applicable. So we want to find something with delta D, VF, A, and V1 in it. So the equation we're going to use is this one right here. So if we make our substitutions, VF is equal to, sorry, this should be V2, just to be consistent. Like that. Oops. V2. So V2 is 0. V1 is 20 squared plus 2 times negative 9.8. And then delta D. And then when this becomes 400, This is negative 19.60. We bring this over to the left side. And then when we work this out, delta D ends up being 20.4. Now, the question's asking us how far are we above the ground. So this blue part here is 20.4. So we just have to tack on the extra 1,000. So therefore, the cannonball goes 20.4 meters above ground. Now for part 2, we look at how long it takes to get from here to here. So that means that we're going to have to use an equation that involves delta t. So for part 2, we are interested in this value because we start here and we end up here. This value will be useful, and so will this value. So we want an equation with delta t in it, with delta d, a, and v1. So we're going to find delta t using delta d is equal to v1 times delta t plus half a delta t squared. Now, because all of these values are non-zero, then we're going to have to use the quadratic formula. So delta d is negative 1,000. v1 is 20. I'm just going to drop the triangles. This ends up being negative 4.9. And then t squared. If we set this equal to 0, we get 4.9 t squared minus 20t minus 1,000. So what I did is I just brought all of the things on the right side here over to the left side. So this is A, that's B, and that's C. So the quadratic formula looks like this. T is equal to negative B plus or minus B squared minus 4AC over 2A. And then we substitute in these values here. So we get T is equal to 20 plus or minus 20 squared minus 4 times 4.9 times negative 1,000 over 2 times 4.9. And this simplifies to 20 plus or minus 20,000 over 9.8. And you get two answers. One is 16.5, and the other one is negative 12.4. Now, this is the one we're going to choose because we're looking for a positive time value. We're looking for the collision of the ball with the ground ahead in time. So therefore, the time it takes is 16.5 seconds. And I know it's in seconds because if we look at our units here, these are all in seconds.